Hey, this is Mr. James. In this video, we're going to be talking about slope, parallel lines, and perpendicular lines. Really, this is our first foray into coordinate geometry, which means we're going to be taking shapes like squares, rectangles, triangles, polygons, and putting them onto a coordinate grid. And so it's going to be very important when we do that to be able to find the slope of different sides of shapes and tell whether different lines are parallel and perpendicular to each other. So that's where this comes in. As always, make sure you're pausing the video when you need to, trying practice problems, and rewinding when you're confused or you miss something. Let's get started. First, let's talk about slope. All slope is it's a ratio of the change in y over the change in x. So it's always a fraction, right? Always a fraction or something like that. When we look at a graph like this, the x is this direction and the y is this direction. So oftentimes, instead of saying change in y over change in x, people say the rise, because that's in the y direction, over the run, because that's in the x direction. So change in y over change in x has another name, and that name is rise over run. Although really it's the same exact thing. We're just putting different words to it. So what do we mean by rise over run? Well, all I've got to do is pick 2 points in our line, any 2 points, maybe say this one and say this one, right there. Figure out how far you've got to go in the x direction. It seems to be about 1, 2, 3, 4, going positive 4 in the x direction, and then up 2, so we're going positive 2 in the y direction, which means my rise, or my change in y, is 2, and my run, or my change in x, is 4. And I can simplify that fraction to 1 over 2, or 1/2, and that is the slope of that line. The slope is 1/2. The second one, it costs $12 for every 6-pack of soda. Well, remember, a slope is just a ratio of two things. So just like here it was our rise to our run, here we're going to make a ratio of dollars per soda. So here it's like $12 in total for 6 cans of soda. And if we simplify that, that is 2 over 1, or $2 per can of soda. Now, this isn't a geometry kind of slope, but it's still a kind of slope or kind of rate of change, and so it's important that we know that we can use slope like that. The third way we can use slope is between 2 points like this. Now, you might be used to seeing this equation, y2 minus y1 over x2 minus x1. And if you'd like, you can label your points x1, y1, x2, y2, and use that equation. But what I prefer to do is just look at the differences in the y's and the differences in the x's and put it as a fraction. Here's what I mean by that. From 2 to 10, those are my 2 y numbers. What's the change? What's the change in y? Well, from 2 to 10, I'm increasing by 8. 2 to 10 is, I'm going up by 8. So I write that down, that's my change in y. That goes on the top of the fraction. And then what about the change in x? Well, from 1 to negative 3, I'm going down. I'm going down by 4. So I'll write negative 4 on the bottom. That's my change in x again. And if I simplify that fraction, 8 over negative 4, well, let's see, 8 over 4 is just 2. And a positive divided by a negative is a negative. So my slope between those 2 points is negative 2. Now, if you wanted to use the formula, that's fine too. You would just be writing, let's see, y2 minus y1. That's going to be 10 minus 2 over x2 minus x1. That's going to be negative 3 minus 1. And in any case, you would get 8 over negative 4. So if you use the equation, the formula, that's fine. You'll just be finding slope using one extra step. But no big deal. Any way you want to do it, that's fine. Next, we need to go to the bottom of our note sheet and talk about slope-intercept form, or y equals mx plus b. This is the equation that we can use to graph a line. Now, what do these letters mean? Well, y and x are variables, but m and b have specific meanings. M is the slope of our line, what we were just talking about, and b is going to be our y-intercept of that line. Let's talk about how to graph using those. So if I were to look at these 2 lines, I'll do one in purple and I'll do one in green. There it is. Okay, how would I graph this? Well, first I'm going to go to my y-intercept, -1, and plot a point right there. And then I'm going to go and use my slope. My slope is, well, my rise is -3, which means I'll go down 3, and my run is 2, so over 2. So down 3, 1, 2, 3, over 2, 1, 2, and make my next point there. And I can continue the pattern the other direction if I'd like to. Okay, and then draw my line. There's the line for that one. Pause the video here and try and draw the line of the next one in green right here. Pause the video now. Alright, the line's about to appear in 3, 2, and there's the line, y equals 2/3 x. Now, a couple things to remember about this. If you're wondering what the y-intercept was, it's not that it doesn't have one, it's that the y-intercept is 0. Okay? 2/3 x plus 0 is the same thing as 2/3 x, so we always start that graph right at 0 on the y-axis. And then, of course, I use the slope up 2 over 3 to get to my next point, and then I draw my line. What about the next one? Well, the next one is y equals 3x minus 1. So again, I'll go to my y-intercept of -1. And now let's see here. What about this 3? Well, what's the rise looks like it's 3, but what's the run? Remember, you could always take your slope and write it as a fraction. 3 over 1. So starting at -1, my rise will be 3. 1, 2, 3. And my run, going forward in the x direction, will be 1. Place my next point. And I could, again, continue that pattern throughout the coordinate grid, and then draw my line. Got broken up a little bit there, but it's almost straight. Pause the video here and try and graph this next one, y equals 3x minus 4. Pause the video now. The answers are coming in 3, 2, make sure you pause the video. Here they are. Alright, and there is our second line in green, y equals 3x minus 4. Remember, you're going to -4 for your y-intercept, and then your slope is over 1 up 3, just like the last one. Let's do one more before we move on. The graph of y equals 2 and x equals -1. So I'll do y equals 2 in purple first. This line is going to be a flat line. You can think of it this way. There's no x in here. It's almost like saying y equals 0x plus 2, because the slope here is actually 0. So in any case, it will be a flat line. The way that I like to graph these is to think, okay, y equals 2. So on the y-axis, I'm going to go to the number 2. And then where else on the y-axis is, or well, where else on my graph is y2? Y is 2 over here, and y is 2 over here. Oftentimes, people will make the mistake of going to 2 on the y-axis and then drawing a vertical line, because they think y-axis is up and down, so the line y equals 2 will also be up and down. But that's not the case. The y equals line is going to be horizontal. Pause the video here and see if you can figure out what the graph of x equals -1 is going to look like. Pause the video, and the answers are coming in 3, 2, 1, and there it is, x equals -1. Remember, I went to -1 this time on the x-axis, okay, and then drew a vertical line straight up and down. That's because everywhere on this line, x equals -1. If I had done something and gone this way, well, I'm now going to places where x equals -2 and -3, and that's just not the case. Okay? So you need a vertical line whenever you have x equals something else. Now that we've done a little bit with slope and slope-intercept form, let's just make a few conjectures, a few generalizations about slope. These will help us check our work whenever we draw graphs or answer questions about slope. So first, what tells us the steepness of the slope? Here I've got a graphing utility that has y equals mx plus b into it, and here is a line. Let me make this a little bold for us. Here's our line, y equals mx plus b. What do you think happens when I make m, the slope, larger? Let's see. When m gets larger, the graph gets steeper. Okay, when m is larger, the graph is steeper. What if I make m more negative? Well, the graph is also steeper the farther negative I go. So the farther away I get from 0, so more positive, or more negative, I guess larger numbers in general, farther from 0, the steeper my my slope is. Let's write that down. So what tells us the steepness of the slope? Well, that m letter of our equation does, the slope. Okay, and it's not just m, we would say it's how far m is from 0, how, I guess you could say, large m is. And so we're going to put absolute value symbols around it, and that means that we're looking at the slope and only looking at it in terms of positive. So if m is large, then we're going to have a steep slope. However, if that slope is small, it's close to 0, maybe it's a fraction, we're going to have a more shallow slope. So if m is small, we're going to have a less steep slope, just like that. Now, what tells us if the slope is increasing or decreasing? Let's go back to a graph for that one. Let's see, right now in this graph, I've got an increasing graph, and my slope is, well, it's a positive number, right? It's increasing. But the second that I go to negative, over here, looks like the graph is decreasing. So if m is positive, that means that I've got an increasing slope. And if m is negative, that slope is negative, then I've got a decreasing slope. That line is going down from left to right. What about a horizontal line? What does it look like? What is its slope? Well, let's go back to our graph one more last time. Now, if I try and make a horizontal line, I get a slope of, let's see, 0. The slope here is 0. Another way we can tell the slope here is 0 is because if I try and pick 2 points, say here and here, my run from one to the next will be, let's see, 3. But my rise, well, I don't have any rise, so that'll be 0. So my slope, rise over run, is 0 over 3, or just 0. So a horizontal line, the slope is 0. And the way to write a horizontal line, like we saw before, is y equals some number. So in this case, this line can be written with y equals 1. Let's jot that down in our notes. So a horizontal line looks like this. It's got a slope of 0. And the graph will always have the equation y equals some number. Back to our graph for one last time. I can try and make a vertical line with this, with y equals mx plus b, but I'm going to have a difficult time. If I try and make my slope steeper, I can keep going, but it can only get so steep. It's not truly straight up and down. For that, I'm going to have to graph a completely different line, like this. X equals 2. Now, I'll make that one blue. Now I've got this vertical line right here. What kind of slope does that line have? Well, again, we could take 2 points, say this one right here and this one right here. Our rise is 3, and we have no run, so our run is 0. So that means that my rise is 3, my run is 0. 3 divided by 0, I can't divide by 0, which means when we divide by 0, we call that undefined. Divided by 0 is undefined in mathematics. So we say the slope of this line is undefined. Okay? And again, the equation of this line right over here is x equals 2. So x equals something will always give us a vertical line with an undefined slope. So a vertical line, again, remember straight up and down. The slope, m, is undefined. And the equation is always going to take the form x equals something, right? Could be like before we saw x equals 2, or it could be something else. But in any case, it's always going to be that vertical, straight up and down line. Alright, in this video so far we've talked about some slope, but we haven't really talked about parallel and perpendicular lines. But go down to the bottom and we'll get to that just next. So what about parallel and perpendicular lines? Well, if we look at the bottom of our note sheet on the front side, we see that actually we have some parallel and perpendicular lines right here. We've got these two lines look like they're perpendicular. They meet at a right or 90-degree angle. These two lines look like they are parallel. They never intersect. And these two lines look like they meet at a 90-degree angle. They're perpendicular as well. Is there a way we could maybe predict that those lines are parallel or perpendicular without actually looking at the graphs? Well, we can. Let's take a look at the parallel ones first. Take a look at the slopes of the two parallel lines. What do you notice? That's right. Parallel lines have the same slope. And that kind of makes sense because they're going in the same direction, so they would have the same slope. What about perpendicular lines? Well, if you look at these, this slope is negative 3 over 2, and this one is positive 2 over 3. So it seems like perpendicular slopes maybe have the same numbers, but you flip the fraction over. 3 over 2 becomes 2 over 3, and you change the sign from negative to positive, or maybe from positive to negative. This is also perpendicular, and that's because this has a slope of 0, and this has an undefined slope, so this will also be perpendicular. Let's solidify this on the top of the next page. So the slopes of parallel lines are the same. The slopes of two parallel lines are the same. So that means if I had a line like this, if I had a line that was y equals 3x plus 1. Let's graph that just so we can see what it looks like. Let's see, go to plus 1, and then my slope is like that. Alright. 3x plus 1. Then if I were to draw a parallel line, I have to draw another line with the same slope. And since the slope of this line is 3, I'll draw another line with the slope of 3. Maybe y equals 3x minus 2. Okay, so I'll go to negative 2, and then I'll use that same slope. Okay. Alright, and draw my line. And yeah, I've got parallel lines, and I can mark those are parallel by putting the parallel symbols on them. Again, parallel lines have the same slope. What about perpendicular lines? Well, the slopes of perpendicular lines are what we call negative reciprocals. So negative R-E-C-R-I-P-R-O-C-A-L-S. Negative reciprocals. What does that mean? Well, if I start with that line that I had before, something like y equals 3x plus 1. I'll just draw that on here just so we can see it again. There we go. There's the y-intercept and my slope. Okay. And there's a rough sketch of that line. What's a negative reciprocal? Well, the word negative means to change the sign. And reciprocal means to flip that fraction over, switch the numerator and the denominator. How do we do that when our slope is just 3? Well, really, the slope is 3 over 1. Remember, we can always put a slope over 1. And so the negative reciprocal would be to flip the fraction, make it something like 1/3. Put that in green, 1/3. And to change the sign, so make it negative. And so I could make a line that was y equals negative 1/3 x, I don't know, plus 2. Go to 2, okay, and then graph this line, so negative down over, okay, just like this. I could draw that line, and look, my line now is perpendicular to the first line because that has that negative reciprocal slope. Another way to remember negative reciprocal is one a student actually came up with last year. What you're going to do is take your original slope of 3. You're going to keep the same numbers. Oops. Keep the same numbers. You're going to flip the fraction. Okay? Flip that fraction over, top and bottom. And you're going to change the sign, positive or negative. And so we kind of abbreviate that as KFC. And so a good way to remember that perpendicular lines have that KFC slope, that keep, flip, change slope. Or you can remember negative reciprocals, but I think KFC is kind of fun. Now, this page is not on your notes, but I want you to pause the video here in a second and just determine whether each set of lines are parallel, perpendicular, or neither. Try and do 1, 2, 3. 4 is a difficult one, so I'll star that. 5, 6, 7, and 8 is also a more difficult one. So at least 1, 2, 3, 5, 6, 7. Pause the video here, and then I'm going to go through these in order to determine whether each of these are parallel, perpendicular, or neither. And remember to look at the slopes of each equation. Pause now. All right, let's take a look. Number 1, the slope of both equations is 2. It's the same slope, which means that those two lines will be parallel. For number 2, the slope is 3 1/3. Now you might think that that's a keep, flip, change slope, that those are perpendicular. But actually, 3 and 1/3 are flipped over the fraction, right? 3 over 1 changes to 1 over 3, but you've also got to remember to change the sign. And the second slope isn't negative, it's a positive 1/3. And so it's not actually keep, flip, change. It's not a negative reciprocal because it's not negative. So this ends up being neither. For number 3, x equals 2 and y equals 5. Well, x equals 2 is always a vertical line, and y equals 5 is always a horizontal line. You could graph those if you wanted to see this a little more specifically, but I know since that's vertical, this is horizontal, this will be a perpendicular set of lines. We'll come back to 4 in a second. For 5, we have slopes of 2 and -1/2. Those are keep, flip, change. Remember, 2 over 1, flip that fraction over, 1 over 2, change the sign to negative. Those are, so those are in fact perpendicular. Something like 6, well, the slopes are 5 and -5, and they look like they're the same, but they're not. One's positive, one's negative, so they're definitely not parallel. And there's no flipping of the fraction, there's no reciprocal, so they're definitely not perpendicular. These are neither. For 7, we've got x equals 2, which is usually a vertical line, and x equals 5, which is again another vertical line. They both have that same undefined slope going straight up. So those are going to be parallel. All right. Taking a look at number 4. Can we figure out what the slopes are of those two equations right away? We actually can't, right? They're not in y equals mx plus b form. So to make things easier, let's put these in y equals mx plus b form. We write them next to each other just like this. Okay, let's take a look at this first one. We need to get this into y equals mx plus b to figure out what the slope is. So here's a y. I need to get y by itself. So I need to move this 2x to the other side of the equation. I'll subtract it from both sides. Okay, and I'm left with y equals. Now I can't combine 3 and -2x because those are not like terms. One has an x, one does not. So that means I'll leave this as -2x plus 3. And so the equation of this line is y equals -2x plus 3. What about the other line? Well, I'll do the same thing. I'll subtract 4x from both sides. So I get 2y equals -4x plus 10. Again, I couldn't combine the 10 and the -4x. It's not like terms, so I just wrote it like this. But y is not by itself yet. There's 2 times y over here. So the opposite of multiplication is division, so I'll divide both sides by 2 to get y by itself. And now I'm going to divide everything on the right-hand side over here by 2. So that leaves me with -2x plus 5. And now if we look at these two equations and their slopes, that has a slope of -2, this has a slope of -2. Actually, those two lines are parallel. They're parallel. They're parallel because they have the same slope. As for number 8 is what we call in point slope form, which we'll work more with in a second. But point slope form looks like this. Y minus y1 equals the slope times x minus x1. And when we look at these up here, that means the slope is this number, 2/3 and -3 over 2. And that is a keep, flip, change slope. So these lines are perpendicular. Now, I hope that this little tangent gave you a little better explanation, a little more practice with parallel and perpendicular lines, especially when some of our assignments, some of our online assignments especially, have to do with telling whether lines are parallel or perpendicular. Let's go back to our notes. All right. In our last segment, we're going to find the equation of a line that passes through the following points. And I'm going to do 2 first. I'm given a point and a slope. And for some of you, that will jog the memory of point slope formula. Point slope formula looks like this. Y minus y1 equals mx minus x1, where m is the slope, and y1 and x1 are the x and y coordinates of a specific point on that line. So for something like number 2, I would write y minus, let's see, the y coordinate of this is 0 equals, the slope is negative a half, times x minus the x coordinate is 5. And now all I've got to do to get this into y equals mx plus b, or that slope-intercept form, is to solve for y. Well, y minus 0 is just y, and then I distribute this 1/2 into the equation. So negative 1/2 x minus negative a half times negative 5 is actually positive 5/2. So that is our equation right there. Y equals negative 1/2 x plus 5/2. At this point, you can actually try and finish this page out if you're pretty good at point-slope form. If not, I'm going to walk through a couple more problems, so keep watching. But if you're feeling good, pause the video here and try and finish 1 to the bottom. Alright, let's go back and take a look at number 1. Again, I'm going to use point-slope formula, which is y minus, well, here's my point, so the y value is the 1, so y minus 1 equals, slope is 3, x minus 1. Okay, so I'll start by distributing the 3 into the parentheses, so 3x minus 3, and I need to bring this negative 1 to the other side, so I'll add 1 to both sides and be left with y equals 3x minus 2. And there is the slope-intercept form of that equation. What about number 3, where you're given just 2 points? Well, you've got 2 points, you can find the slope, okay, and then after you find the slope, you could use one of the points and that slope you just found to and point slope formula just like we did before. So let's see, what's my slope here? Change in y. 2 to negative 2 is decreasing by 4. Change in x. 1 to 5 is increasing by 4. So my slope is negative 4 over 4, which simplifies down to negative 1. Great, now I've got a slope, and I will use this point. So again, point slope form. Y minus, I guess, 2 equals negative 1. That was my slope from before, times x minus 1. So simplifying that, I get y minus 2 equals negative x plus 1. Again, I could distribute that negative 1 in there. And then I add 2 to both sides, and I get y equals negative x plus 3. Now these next 3, I'm just going to give you some hints and let you try them yourself, and then have the work pop up at the very end of this video. So for number 4, they give us an x-intercept and a y-intercept. Now those aren't points, but we can actually get points from those. If you think about an x-intercept at 4 and a y-intercept at negative 6, those have specific points. If we look right here, an x-intercept at 4 has the point 4, 0. And a y-intercept at negative 6 has the point 0, negative 6. So my points are 4, 0 and 0, negative 6. And you can finish this just the same way you did number 3 with 2 points. For number 5, they're telling us it's through this point and parallel to this line. Now, the only important part of that line is the slope. We talked about if we want to draw a line with a parallel slope, we will use the same slope. So for this line, we will use that point and a slope of 2. For number 6, we'll use the same point, but now a perpendicular slope, which means that we're going to take the slope from this line and do the key flip change. So the slope of our new line will be negative 1/2. So using those hints, pause the video here, and at the very end, the work will pop up. When you're done with the video, make sure you try your homework and the classwork, and I'll see you next class. Here's the work and the answers. Pause now so you can see it for longer.